and welcome to the video lecture on the physical database design process. So here we're going to talk about what inputs we have and what decisions need to be made. Right, so the inputs are normalized relations, right? So we've spent a lot of time in the logical design process creating normalized relations. I've had a lot of people talk about them and make decisions on what attributes, what entities, what are relationships. All that stuff has already been discussed. Then we need to develop what are our volume estimates. I'm going to get into that in a couple of slides after this in a different video, but we have to come up with volume estimates. How much data are we going to be keeping? How is it going to grow? In other words, let's make a volume estimate for this year, right? But then we're expecting our business to grow. So if our business grows, our data consumption and volume is going to grow as well. And then volume is not just as far as the size of the data, but it's also the speed of the data. So we're going to talk about that in just a second as well. We're going to talk about attribute definitions, right? So now we're going to get very specific about our attributes and defining them. We'll talk about that again in a few moments as well. So then associated with volume estimates, we also have response time expectations. How fast does this data need to come back? And who needs to come back at what speed? When we're talking about the CEO is probably going to want to click a button and have the report come back virtually instantaneously, whereas our line level supervisors and lower level managers may be able to wait 30 seconds or so, 4 minutes for a report to come back. We're going to need to talk about data security needs, right? How secure do we need to make this database, which is going to affect response times because of all the security levels that we may have to put in place. Again, our backup and recovery needs. How long do we keep the data? How secure does our backups need to be? How often are we going to run tests on backing up? Because again, it's pointless to back up if you don't test your recovery process. You can have all the backups in the world. When push comes to shove and you actually lose all of your data and you need to recover, if you're unable to recover from the backups you've been keeping, they're pretty useless. And at this point, I'm going to tell you that you should be backing up your computers at home. We're going to talk about backing up later on, but seriously, think about what would happen if your computer crashed today and you lost all of your data, all your pictures. So think about that. You should have an external hard drive or using iCloud or something like that to back up your data. Integrity expectations goes into, what controls are we putting in place to keep our data from getting damaged, right? So there's, what are those expectations? They could be very high, they could be fairly low. There's a cost associated with that. And that's going to lead us into what database management system are we going to use. I talked about that in the previous video. Are we going to use Oracle? Are we going to use Access? Are we going to use SQL Server, DB2, MySQL, whatever? All of them have costs and benefits associated with them. So once we've determined all of that, and that should come from our logical database design, then we're going to make our physical design decisions, right? We're going to talk about data types. What data types are we going to use to efficiently store our data? Physical record descriptions. These are not always going to match what your logical designers put into place, because now we're talking about physical design, we're talking about performance. So we're going to be making changes to the logical design when we're making our physical design. We're going to talk about file organizations, 3 different kinds. And we'll talk about that in later videos. We're going to talk about indexes and database architectures, right? So there's actually going to be architectures associated with the database, usually associated with file organizations. And there are going to be indexes which are going to improve performance as far as reporting, but they also have a cost associated with performance as far as data entry. And then we're going to talk about query optimization, which is going to lead us into Chapter 6 when we talk about SQL. We introduce you to SQL. And that is the end of the Physical Design Process lecture.